Dimensional analysis can take many different forms. Sometimes you will see it as fractions in parentheses multiplied by other fractions or ratios in parentheses. Sometimes you will see it as the train tracks method, which I prefer the least because it kind of neglects some of the mathematical symbology in there. And sometimes you will see it as fractions multiplied by fractions with a visible bar or dot in between. They're all equivalent. I prefer this method, but whatever method you have learned or will learn, they are all equal mathematically, so long as you understand what math is actually taking place. So with dimensional analysis, I look at what I have, and I say to myself, I'm going to put that down first. I call that what you know. The only value I really know that is unique to the problem is 0.17 miles. And I tend to put that value over 1 if it's a single dimension. For example, this is going from miles to centimeters. It is not going from miles per hour to meters per second or some other type of rate. So 0.17 miles, I put it over 1 just to keep my heights the same. Numerators and denominators are all on the same level, and it kind of helps visually. It is completely optional. When you have a unit that you're starting off with, such as miles, and you want to get away from that unit and toward a different unit, such as centimeters, you need to put the unit that you do not want in the opposite position of the fraction bar. Because miles is in the numerator, to start, I need to put the unit of miles in the denominator next door. That will cancel it. At this time, you need to think about where you're going. Of course, you're going to end up with centimeters, but there are steps between, and that is kind of how dimensional analysis or unit conversions work. The steps between miles and centimeters that can help you think about how many there would be in one or the other would be, for example, using this conversion factor, miles to feet. This is a conversion factor. A conversion factor tells you how two units are related. Sometimes they're connecting what you have to what you're going toward, and sometimes it's just one of the steps in between. This is also a conversion factor. You may need both, and the thing about conversion factors is either you must know some by heart. For example, you know that 60 seconds is 1 minute, or that 12 inches is 1 foot. If it's not something that your course expects you to know by heart, you have to be given it, or you can look it up as a conversion factor. Feet and miles are related because 1 mile is 5,280 feet. The smaller unit, such as the feet, will have the bigger number. And miles, which are bigger than feet, will have the smaller number. And that makes sense because it takes lots of smaller feet to make up one big mile. Continuing, you've got feet as your unit that you currently have because you canceled out miles. Get rid of feet by putting it at the bottom. We're going to go from feet to trying to get towards centimeters. We know that feet and inches are closely related. And I'm going to show you another trick that I do. Sometimes I fill in all the units in the way I want them to cancel, and then I put the values, the numbers in. So inches are going to go at the bottom because they're at the top next door, and I want them to go away. Ultimately, I'm looking for centimeters. And here's how the units cancel. Feet cancel, top and bottom. Inches cancel, top and bottom. Centimeters don't cancel, so I tend to circle a unit when I want to stop. Putting in the values is important. 1 foot is 12 inches, and 1 inch, according to the conversion factor that you may not know, is 2.54 centimeters. When you do the math, you get approximately 27,000 centimeters. I rounded this number to 27,000 because it uses two sig figs. If you don't know what sig figs are, you will learn them at some point if you're taking a chemistry or physics course. If you don't need to know them, then I would say don't worry about it, because when you put this into your calculator, the number would really be 27,358 and some other junk. But this number is appropriate to do sig figs. This second example asks us to convert 2 kilometers into inches. As you would expect, we're going to start with what we know, which, if you want to think about it this way, it is the thing that can always change in the problem. For example, if you were taking a class and the teacher gives out 3 different versions of a test, he or she may change 2 kilometers to 3 kilometers or 1.5 kilometers for different people on the different versions. But what will never change is the conversion factor. 1 inch will always be this many centimeters, 1 mile will always be this many feet and that many kilometers, and 1 meter will always be this many centimeters. So a conversion factor is not something that you know per se. It is something to help you get what you know to where you're going. We have 2.00 kilometers. Now back to the sig figs discussion real quick. We have 3 sig figs, 3 significant figures in our starting value, and we would get 3 significant figures in our ending value because all of our conversion factors have 3. But more importantly, some conversion factors are exact conversions. For example, 1 meter is exactly 100 centimeters. So you would not use the fact that 100 looks like a single sig fig. That is just a blur for people who are wondering where sig figs fall into this. If you are not dealing with sig figs, don't worry about that. There are plenty of help videos on sig figs too. 2.00 kilometers over 1. I'm going to do the skeletal method where I put all my units and the way they will cancel before I deal with any numbers at all. And this really helps some people in my experience. I'm going to go from kilometers to, and you got to think a little, kilometers to meters or kilometers to miles. There are many different ways to do different dimensional analysis problems depending on what you personally know in your head as far as conversion factors and what are provided. I can go from kilometers to miles using this conversion factor that was graciously provided to me. So kilometers to miles says that because a kilometer is a little bit smaller than a mile, it takes a little bit more than 1 kilometer to make up a mile. So 1.61 kilometers makes up 1 mile. I'm going to show the cancellation. I'm going to go from, and I kind of broke my rule. I said I would put the units in before I put the values in. I kind of go back and forth. It depends. They all give you the exact same answer, so I will continue with what I was saying. I'm going to go from miles to feet, and then from feet to inches. And here's the cancellation. Miles cancel top and bottom. Feet cancel top and bottom. And then if you do what I do occasionally and you put in the units, how they will cancel before you put in the values, putting in the values should be simple. There are 5,280 feet in 1 mile, and there are 12 inches in 1 foot. Doing the math for this, you will get an answer of approximately 78,700 inches. The second part of this video will have 2 more examples that are a little bit more complicated.